They looked at him, a farmer with a spool of wheat and a ridiculous idea. But weeks later, Shermans were killing tiger tanks 3 times faster. This isn't a story about technology. It is the story of how honestly trick rewrote tank warfare and saved thousands of men from burning alive.
By late 1943 and into 1944, the Western Front had become one of the most unforgiving landscapes for Allied tank crews. The M for Sherman, fast, reliable, and easy to mass-produce, was never designed to fight the armored heavyweights Germany was now fielding. Yet on the plains of France, in the bocage of Normandy, and in the forests of Belgium, this medium tank had become the backbone of American and British armored forces. Inside a Sherman, conditions were brutally simple. The thin armor, barely 50 millimeters on the hull front, turned the interior into a metal oven. Temperatures often exceeded for OC under fire. When a German 88mm round impacted the armor, even without penetration, the concussion shook the crew so violently that vision blurred and ears rang. Metal fittings rattled, ammunition clanged, and the tank filled with the sharp sting of cordite and hot oil. Against the German Tiger I and, later, the Tiger II, the Sherman was outmatched in almost every measurable category. A Tiger could engage a Sherman from 1,500 to 2,000 meters, well beyond the range at which the Sherman's 75mm gun could reliably penetrate German armor. For many crews, the first sign of a Tiger's presence was not its silhouette, but the sudden arrival of a high-velocity round tearing through their formation. Allied intelligence reports from the summer of 1944 recorded grim statistics. In Normandy, some tank battalions were losing half their Shermans within weeks. Even the British Firefly variant, equipped with the powerful 17-pounder, struggled when caught out of position. German heavy tank units, such as Panzerabteilung 503 and 101, demonstrated repeatedly that a handful of Tigers could blunt or completely stop entire Allied armored advances. The strategic crisis deepened as the fighting intensified. American factories were building Shermans at an astonishing pace, nearly 2,000 per month by mid-1944, but the front consumed them almost as quickly. Reports from commanders like General Omar Bradley reflected a growing concern. The United States could replace tanks faster than Germany, but it could not replace trained crews at the same rate. Every destroyed Sherman represented 5 men whose survival depended on seconds, angles, and sheer luck. The psychological weight of facing a Tiger was heavy. Sherman crews often spoke of firing first and watching their shells ricochet harmlessly. The metallic thud of a round bouncing off a Tiger's glacis, an impact that should have been lethal, was a moment of helplessness burned into memory. Even when numerical superiority favored the Allies, the imbalance in quality meant that a single German heavy tank could dominate the field until maneuver, artillery, or pure attrition brought it down. Europe was turning into a graveyard of Shermans, not because they were poorly designed, but because they were fighting a tank they had never been built to confront head-on. This crisis, raw and urgent, created the environment in which even the smallest battlefield innovation could shift survival odds dramatically. The stage was set for a simple, improvised idea to make an outsized impact. Long before many Allied soldiers saw a Tiger tank, they heard about it. Its reputation spread faster than its actual deployment. By numbers alone, it should never have carried such influence. Only about 1,350 Tiger I and 492 Tiger II tanks were ever produced. Yet from Tunisia to Normandy to the Eastern Front, crews described encounters with Tigers in terms usually reserved for natural disasters. The Tiger I, introduced in late 1942, quickly became a symbol of German armor dominance. Its 88mm KWK-36 gun, derived from the feared 8.8 cm flak anti-aircraft weapon, was capable of destroying most Allied tanks at distances where return fire was ineffective. Combat reports from North Africa described Shermans being knocked out at ranges exceeding 1,500 meters. In the same moment, their own rounds turned into harmless sparks against the Tiger's thick, interlocking armor plates. The Tiger's myth grew from real battlefield effects. Units like Panzerabteilung 501 and 502 demonstrated that even a handful of well-crewed Tigers could stall larger formations. In Normandy, SS Panzerabteilung 101, home to commanders like Michael Whitman, showed how rapid, aggressive tactics with Tigers could wreak havoc on Allied columns. These stories circulated widely among troops, and with each retelling the Tiger grew larger, more invincible, more omnipresent. Veteran Sherman crews recognized the sound of a Tiger's engine before they saw it. The Maybach HL-30 produced a distinct, heavy rumble that echoed through bocage lanes and resonated across open fields. The first, sighting often a broad turret, thick frontal armor, or the unmistakable silhouette triggered immediate caution. Radio chatter frequently included phrases like 88 ahead, a shorthand that instantly elevated the threat level. Technical superiority was only part of the Tiger's power. Its psychological effect was magnified by its scarcity. Because Tigers were deployed in small, elite heavy tank battalions, their appearances were infrequent but deadly. Many Allied soldiers believed that Germany had far more Tigers than it actually did. A single Tiger halting an entire company reinforced the myth. After-action reports from the U.S. 2nd Armored Division and British Guards Armored Division describe battles where the presence of just 2 or 3 Tigers dictated the movements of dozens of Shermans. The Tiger II, or Kriegsstiger, introduced in 1944, intensified these fears. With 150 mm of frontal armor and the long-barreled 88 mm KWK-43 gun, it represented an even higher tier of threat. Allied crews facing the King Tiger often remarked that the only reliable tactic was to avoid the front entirely. Even when outnumbered, these German heavy tanks held psychological initiative. Allied commanders understood the danger. Hesitation on the battlefield could cost lives. Just as quickly as armor thickness, the Tiger was not myth because it was invincible, but because it forced every opponent to rethink their approach to armored warfare. This dominance, both real and perceived, defined the battlefield environment into which new tactics and small innovations became not just useful, but urgently necessary. The Allied armored forces of the Second World War were not composed of lifelong soldiers. By 1944, many Sherman crews came from backgrounds far removed from the profession of war. American records from the armored force at Fort Knox show that a significant portion of new replacements had only a few weeks of training before deployment. Their pre-war occupations reflected a civilian nation suddenly thrust into global conflict. Farm laborers from Iowa and Kansas, auto mechanics from Detroit, warehouse clerks from New Jersey, and factory workers from Pennsylvania. These men entered a world of engines, steel, and lethal precision with experience that was practical rather than military. A farm boy who had repaired tractors and threshing machines understood the value of mechanical reliability. A mechanic who had rebuilt engines knew instinctively how to read the sound of a misfire or a stressed gearbox. These skills translated directly into the rhythms of armored warfare, where survival often depended on keeping a tank functioning under the strain of mud, shrapnel, and long marches. Improvisation became a defining trait of these crews. Field reports from units like the U.S. 3rd Armored Division frequently describe modifications carried out with welding torches, spare parts, and whatever scrap metal could be found on abandoned vehicles. Additional track links were bolted onto hull fronts for marginal protection. Ammunition racks were reorganized to reduce the chance of catastrophic fires. Commanders added makeshift sunshades, extra radio mounting points, and improvised stowage racks. Among these thousands of ordinary soldiers was an unnamed enlisted man, one of many whose background on a family farm shaped his instincts inside a Sherman. Such men were not engineers by training, yet they understood machinery as a practical craft. They recognized inefficiencies intuitively, seeing flaws not in terms of official manuals, but through the mindset of a mechanic trying to make a tool work better. This civilian foundation mattered. Tank doctrine evolved quickly, but battlefield adaptation often moved faster. When confronted with a complex battlefield problem, orienting a turret rapidly, under pressure, coordinating movement in chaotic terrain, or compensating for blind spots, these crews relied on the same improvisational habits they had developed long before the war. Their solutions were rarely elegant, but they were effective. In a conflict defined by industrial might and technological escalation, much of the frontline innovation came not from laboratories, but from the hands of civilians in uniform. They were men learning to fight a mechanized war with the instincts they carried from home, instincts that, in moments of crisis, could make the difference between life and death. German heavy tanks presented an intimidating profile from the front. The Tiger I's 100 mm frontal armor and interlocking plate construction made it nearly impervious to the standard 75 mm rounds fired by most Shermans. The Tiger II increased this protection even further, adding a sharply sloped glacis 150 mm thick, In head-on engagements, Allied tanks were at a severe disadvantage, but the Tiger's design contained a vulnerability well understood by armored warfare theorists. Its sides and rear were significantly thinner. Tiger's side armor measured 80 millimeters. The rear was even less. The Tiger II, while improved, still presented exposed surfaces that could be penetrated by a well-positioned Sherman, armed with either the 76 millimeters gun or the British 17-pounder. This weakness was not a secret. Allied manuals and intelligence analyses documented it clearly. Yet exploiting this advantage on the battlefield was far more difficult than it appeared on paper. One major obstacle was turret traverse speed. Shermans relied on a hydraulic system powered by the main engine, which was reasonably quick but required coordination between driver and gunner. Under stress, alignment took precious seconds. By contrast, Tigers had slower turret rotation, but their superior armor allowed them to control the first engagement. If a Sherman needed more than a moment to orient itself, the encounter was usually lost. Visibility was another challenge. Sherman suffered from limited periscope views and narrow driver's sightlines, particularly in enclosed terrain like the Normandy bocage. Identifying a Tiger's flank required both awareness and angles that were rarely available in dense hedgerows or cramped village streets. Radio confusion compounded the problem. Although U.S. tank units were far better equipped with radios than their German counterparts, battlefield noise, overlapping unit chatter, and rapid movement often led to miscommunication. Instructions to flank an enemy tank could be lost or misinterpreted, leaving crews isolated or exposed. Stress and battlefield shock were constant pressures. After-action accounts from the 4th Armored Division describe crews who, upon spotting a Tiger, instinctively halted or fired immediately even when their shots had no chance of penetration. This hesitation made coordinated flanking maneuvers rare and difficult to execute. In truth, the Allies didn't need heavier armor or larger guns to counter the Tiger. They needed a way to move faster, position more effectively, and react instantly when a target appeared. The tactical solution existed, but the practical ability to achieve it on chaotic battlefields lagged behind. The breakthrough would not come from redesigning the Sherman. It would come from improving how crews used the machine they already had, transforming their ability to maneuver, align, and exploit the Tiger's blind spots with greater speed and precision. Sherman crews learned quickly that the difference between survival and destruction often came down to seconds. One of the most consistent problems reported in after-action summaries was turret alignment. Under ideal conditions, a commander could orient the turret using the periscope sighting marks. But in combat, when the tank lurched over uneven ground, when smoke filled the air, when adrenaline overwhelmed precision, crews routinely lost track of turret direction. A gunner might be aiming at a target the commander could not see, or the driver would turn the hull while the turret lagged behind, leaving the crew momentarily disoriented at the worst possible time. This issue appeared not in theory, but repeatedly on the battlefield. Units like the U.S. 4th Armored Division and 2nd Armored Division documented how turret disorientation during rapid maneuvers caused missed opportunities and fatal delays. The Sherman's hydraulic traverse system was quick, but its effectiveness depended on crew coordination that often collapsed under fire. It was in this environment that a simple battlefield modification emerged. One crewman, representative of many enlisted men who had grown up repairing farm equipment, recognized the fundamental problem. The periscope markings didn't give the commander an immediate, instinctive sense of turret alignment. The solution did not come from technical manuals, but from the improvisational logic common among soldiers accustomed to making tools work with whatever materials were available. He attached a thin wire, or alternatively a piece of durable string, to the turret in a straight line toward the hull front. The wire acted as a fixed indicator, visible from the commander's position. When the turret rotated, the wire's angle provided an instant, unmistakable cue showing exactly where the gun was pointing relative to the tank's direction of travel. It looked crude. Other crews reportedly laughed at similar improvised alignment markers, calling them farmer tricks or field nonsense. But when tested under combat conditions, its effect was immediate. The commander no longer needed to rely solely on periscope notches while under stress. He could simply glance at the wire and shout the correction, left, right, on target. During the chaos of an engagement, smoke drifting across the field, machine gun fire rattling the armor, the turret snapped onto targets faster than before. A problem that had cost seconds was reduced to an instant. The crew's reaction was not celebration, but a stunned recognition. This was something obvious, something anyone could have built, yet no official system addressed it. The silly wire was simple, but on a battlefield where seconds meant survival, it was transformative. The first real test of the improvised alignment system came under conditions that tank crews knew all too well: limited visibility, broken terrain, and the looming threat of German heavy armor. Reports from frontline units showed that Tiger tanks were often encountered unexpectedly, appearing at the edge of a tree line, emerging from behind a ridge, or positioned hull down in defensive ambush. As the Sherman crew advanced, the tension inside the tank would rise in a way veterans later described with stark clarity. Every creak of the suspension, every radio call from neighboring vehicles, carried the possibility of enemy contact. The air inside the tank grew hotter as the engine labored uphill. Crewmen monitored their sectors, each aware that a Tiger's first shot could decide the encounter. When the German heavy tank finally appeared, likely a Tiger I based on typical 1944 engagements, it emerged in the worst possible orientation, presenting its strong frontal armor. Standard procedure demanded maneuvering for a flank shot, but such movements often became chaotic. In previous battles, turret misalignment during these maneuvers had cost Shermans precious seconds. This time, the difference was immediate. As the driver swung the hull to exploit the Tiger's exposed side, the commander glanced at the wire indicator. Its angle confirmed the turret's orientation instantly. Without hesitation, he issued the firing order. The gunner brought the 75 or 76 millimeters cannon onto the target with fluid precision, far faster than in any prior engagement. The shot struck the Tiger's flank armor, an area vulnerable even to medium-caliber Allied guns. Battlefield accounts routinely described how flank hits could ignite ammunition or fuel, and in this case the impact produced a burst of flame. German heavy tanks, despite their strength, were not immune to internal fires once penetrated. For the Sherman crew, the moment was both shocking and decisive. A tank that usually required deliberate, coordinated effort to defeat had been engaged with unprecedented speed. The engagement did not reflect superior firepower, it reflected superior reaction time. Word spread quickly. Other crews replicated the modification, sometimes adding painted alignment marks, rods, or welded guides. Informal reports from armored battalions suggested that crews using such indicators could acquire targets up to 3 times faster, particularly when maneuvering under pressure. The battlefield had confirmed what no manual had predicted. A simple wire could shift the balance against one of the war's most feared tanks. Field innovations in armored warfare often moved faster than official doctrine, and the improvised turret indicator was no exception. In the weeks after its first successful use, crews from neighboring Sherman platoons began noticing the odd wire or string stretched across the turret of one vehicle. At first, many reacted with amusement. Tank battalions were full of improvised add-ons, extra track links, welded plates, makeshift stowage racks, and this new contraption looked no different. Another piece of frontline creativity with questionable value. But curiosity led to experimentation. Crews who tried the alignment wire during live-fire exercises immediately felt the improvement. Turret orientation, a process usually delayed by confusion or momentary disorientation, became instinctive in armored engagements where seconds mattered. This clarity made a measurable difference. After-action notes from several U.S. armored units mentioned turret aim guides, improvised alignment marks, or field-made turret indicators appearing more frequently across the front. Company commanders began to see a pattern. Shermans equipped with these simple guides were engaging faster and surviving longer. In a theater where German heavy tanks inflicted disproportionate losses, even marginal gains were significant. The modification spread informally, carried by word of mouth, shared tools, and the natural competitiveness among tank crews determined to improve their odds. The idea eventually reached rear area workshops, where ordnance teams refined the concept with metal rods, welded plates, or painted turret reference lines. While never standardized in formal U.S. Army technical manuals, the concept was openly encouraged by officers who recognized its practical benefits. Even manufacturers took notice. By late 1944 and 1945, minor design adjustments and added turret reference markings appeared on certain production runs, reflecting lessons drawn directly from frontline improvisation. For Sherman crews, the alignment trick provided something deeper than mechanical advantage. It offered relief, confidence, and the rare sense that they were finally meeting the enemy on equal terms, not through superior armor, but through superior adaptation. As the Allies advanced through France, Belgium, and into Germany, the battlefield narrative surrounding the Tiger tank began to shift. The vehicle remained formidable, but the aura of invincibility that once defined it started to erode. Sherman crews, armed with better maneuver tactics and faster turret alignment techniques, were no longer entering every engagement at a disadvantage. The Tiger's dominance had rested on two pillars: superior firepower and psychological shock. Once Allied crews realized that positioning and reaction speed could offset these strengths, the psychological balance changed. Reports from the 3rd and 4th Armored Divisions showed that flanking maneuvers became more decisive and more frequent. With quicker turret acquisition, Shermans could exploit the Tiger's weaker side armor before German gunners could reorient their heavy turrets. The Tiger's logistical and mechanical drawbacks also became more visible. As German supply lines collapsed, breakdowns, fuel shortages, and limited spare parts left many Tigers abandoned or destroyed by their own crews. Allied intelligence summaries from late 1944 noted that the fear once associated with Tigers was diminishing, replaced by a pragmatic understanding of their vulnerabilities. The wire alignment trick did not turn the Sherman into a superior tank, it turned its crews into more efficient fighters. The ability to react instantly, coordinate movements, and fire accurately under pressure reduced the Tiger's advantage significantly. A tank that once dictated the terms of battle now found itself hunted more aggressively and outmaneuvered more consistently. By early 1945, the Tiger had lost much of its symbolic power. To Allied crews who had survived earlier campaigns, it was no longer a mythical juggernaut. It was a heavily armored vehicle with blind spots, dangerous, but not untouchable. The collapse of the Tiger's psychological dominance signaled a broader shift in the war. Adaptation, not raw strength, was now determining who lived and who did not. Wartime innovation often emerges from a contradiction. Armies invest heavily in advanced weapons, precise engineering, and complex doctrines. Yet some of the most transformative changes come from solutions so simple that they are almost overlooked. This pattern appeared repeatedly during the Second World War, where frontline adaptation frequently outpaced formal military planning. Large institutions, especially military ones, tend to privilege expert-designed systems. Bureaucracy, hierarchy, and rigid doctrine create environments where new ideas must climb long chains of approval. Even effective solutions can be dismissed if they fall outside established procedures. Pride also plays a role. Many commanders and engineers resist adopting an idea that appears crude, improvised, or lacking technical sophistication, even when evidence supports its usefulness. The improvised turret alignment wire fit this pattern perfectly. It was functional, inexpensive, and easily replicable, yet it originated from enlisted soldiers rather than official departments. It demonstrated a principle often seen in war: the closer a person is to the problem, the more likely they are to recognize a practical solution. Historical parallels reinforce this theme. In Normandy, American tank units struggled with hedgerows, dense earthen barriers that stalled armored advances. The solution, known as the Rhino device, came from Sergeant Curtis G. Killen, who repurposed steel from German beach obstacles to create pronged cutters welded to the front of Shermans. What began as a field experiment became widespread across the U.S. First Army within weeks. A similar story had unfolded earlier in the Pacific. Infantrymen modified the M1 Garand and Thompson submachine guns with field-expedient adjustments, improved slings, wrapped grips, and reinforced stocks responding directly to jungle conditions that official designs had not fully accounted for. These modifications were not complex, but they enhanced survivability in environments far removed from factory testing grounds. Even highly advanced equipment bore the marks of simple truths. The Norden bomb sight, celebrated for its precision, was ultimately dependent on basic mechanical reliability and the training of the men using it. When fog, smoke, or weather interfered, crews improvised aiming adjustments that could matter more than the device's engineering. The turret alignment wire belonged in this lineage of practical ingenuity. It solved a problem no engineer had designed for: the human stress of combat. Under fire, fine motor skills and careful calibration faltered. A simple visual reference, a wire against the turret's arc, provided clarity when seconds mattered. It did not require expertise, only intuition. In war, the simplest ideas often survive because they demand the least to implement and offer the most immediate results. They reflect the mindset of soldiers who cannot wait for new doctrine or redesigned machines. They adapt with what they have, and sometimes, those adaptations reshape the battlefield more effectively than any official innovation. As the war drew toward its end, thousands of Shermans continued fighting across Europe. Some rolled through the ruins of Aachen and Cologne. Others pushed across the Rhine or advanced through the forests of the Ardennes. Many of them carried small, barely noticeable modifications, painted marks, welded guides, or simple wires stretched from turret to hull. These traces of frontline adaptation rarely appeared in official histories, yet their influence was felt in every engagement where reaction time meant survival. The unknown soldier who first attached a wire to his turret did not design it for recognition. He solved a practical problem in the most direct way he knew, his experience shaped by repairing equipment, reading machinery, and relying on intuition became part of a larger story about the power of ordinary individuals in extraordinary circumstances. History often highlights the generals who devised strategies, the engineers who built the machines, and the politicians who directed national efforts. But the battlefield was shaped just as profoundly by the hands of enlisted men improvising solutions under fire. Their small innovations, scattered across hundreds of units, accumulated into meaningful advantages. The turret alignment wire was one of these contributions, inconspicuous, unrecorded in many reports, yet undeniably impactful. Its legacy extended beyond its immediate effect. By helping Shermans engage faster and maneuver more effectively, it weakened the psychological hold of the Tiger and accelerated the erosion of Germany's armored dominance. The Sherman did not become stronger. The men inside it became more capable. When the war ended, most of these improvised devices were discarded, replaced, or forgotten. But the principle they embodied endured. The machines of war may define an era, but the ideas that change. Battles often begin with individuals whose names history never records. History remembers the tanks, but it is built on the minds and the ingenuity of the men inside them.